This video will familiarize you with the fundamentals of processing unstructured data of log files on Hive processing platform. Diota supports a multitude of data sources, such as structured, semi-structured, or unstructured. Diota has the ability to easily extract, transform, and load data into target platforms optimally to gain complete visibility. One of the prevailing industry scenarios in the modern data landscape is that a massive amount of data resides in data lakes. Organizations need to perform some data alterations to further take it for analysis and visualizations. In this demonstration, we will take an example of unstructured data of the server log file in Hadoop and process it through Hive to produce useful insights and load the data into a Cassandra data object. Let's begin and review the detailed steps involved in this process. Data processing in Diota is performed using the transformations within the data flow. Diota provides various set-based transformations, such as joiner, splitter, filter, rollup, and union as data moves from the source to target. Diota exposes all of the native functions of the processing platform, in this case, Hadoop, as functions that are applied as per the business rules. Additionally, we can create user-defined functions, or UDFs, and leverage them inside the data flow using expression transformations. In this illustration, we've used the pre-imported HDFS and Hive data objects through a Hadoop data point. Let's take a look into the Hadoop data point. We have selected the Hive process engine and enabled high availability for failover. The runtime properties are set by default, and the required fields are provided for Hadoop ecosystem components under Settings. Let's review the data flow on the Hive processing platform. We have the source objects as log file in HDFS and the suspicious data objects in Hadoop. Let's toggle the interactive button to on mode to enable the view data feature for the objects in the data flow. We can view the suspicious data in the lower pane to see if the suspicious IP address are as desired. The source file consists of the unstructured data of server logs in a single column called event. We will use an expression transform to convert this into structured data for further processing. The DFS source object is linked to the expression transform. Select the expression transform, and under Attributes, we can define and extract the required attribute values using a regular expression condition. These regular expressions will parse the log file to extract the text. Diota allows us to view data anytime during the transformation. Let's view the expression data to see if the attribute values are as desired. As confirmed here, we have the structured data. Let's split this data and route out these data sets to different targets using splitter condition. Here we have defined 4 splitter conditions. The good condition extracts the good server request data with a response code equal to 200. The bad condition extracts the bad server request data with a response code not equal to 200. The all and stats condition redirects all the data to the linked target object for further processing. Next, to redirect data from the splitter transform into the target table, we used the predefined target object in Cassandra and linked the splitter condition of good and bad respectively. Let's review how we can further process the data using the joiner transform. To keep track of the suspicious hits on the server, join the third splitter condition dataset result with the suspicious data object on Hive containing the suspected IP address. We can load the resultant data set into the predefined Cassandra suspicious data object by automapping the attributes. Next, to get the count to the different request types, such as get, post, head at given timestamp, we have used the expression transform to hold the required attributes from the 4th splitter condition. The expression transform is linked with rollup transform to get the total count based on grouped attributes that is requested type and timestamp. The rollup transform is linked to a predefined Cassandra target table, and the required attributes are mapped under Attribute Mapper. Once the data flow design is complete, click on Save and then Run to execute the data flow. To check the execution status, either click on View Execution Status or go to the Activity screen in the Monitor module. Our data flow has run successfully, and the records have been loaded into the target table after processing. expand the data flow, and view the units within the data flow as well as the statistics. The data has been processed as expected, and the processed data has been loaded into the target table. To orchestrate this data flow as a job, we can create this job as a job flow, add parameters, and define dependencies on other jobs. We can also orchestrate via file watcher or time-based triggers and schedule the job flows via Diota scheduler on any externally available scheduler. This concludes the short tutorial of weblog analysis on Spark using Diota. Thanks for watching. Visit support.diota.com for additional knowledge base articles and tutorials.